Okay guys, let's take a look at today's lesson. This is actually the last lesson that we have in this unit. It is probability with combinations. And so let's take a look. It's a different way to do probability than we learned yesterday or the day before yesterday. There are really two methods that we can choose from. One is called conditional probability, and the other one would be using probability with combinations. And so this is the method that we're going to learn and focus on today. You may already know how to do this, but we're just going to focus on this type today. So if our situation is we have 5 cards are drawn at random from a standard deck, find the probability that all 5 cards are hearts. So we're going to look at both types of ways to do it. This is the traditional way where we would think about, okay, what's our first card? Our first card we're choosing out of 52, and I have 13 cards to choose from. So this would be the probability of getting a heart, 13 out of 52 for one card. And, so multiply, and I want my second card to be a heart, and there's only 12 hearts left and only 51 cards left, and that would be the probability for the second card. And the third card, well, I still want a heart, and there are only 11 hearts left, and there are only 50 cards left. So you see what we're doing? We're just, we would do that for all 5 cards, and then we would multiply all these numbers together, and we would get this probability. Okay, so that's one way to do it. The other way that we're going to focus on today is using combinations. So same scenario, I want the probability of getting all hearts. So the total cards that I have to choose from, there are 52 cards I have to choose from, and I'm choosing 5 cards, right? And it's a combination because it doesn't matter the order I choose the cards in. So I have 52 cards, I'm choosing 5 of them. In the numerator, it's what I want, right? Probability is what you want over total. What I want is all of the hearts. I want all 5 cards to be a heart. Well, there are 13 hearts, and I want all 5 of my cards to be a heart. So the numerator is 13 combinations 5, or choose 5 if you want to say it that way, and that will give me the exact same answer as the other way. Okay, so I encourage you to practice this way today with combinations. That's what we're going to be working on. I want to talk to you a little bit about calculator syntax. So you know our calculators love using the E thing. I know you've seen that before, right? E. It's a calculator syntax thing. It's not a real thing. Okay, it's not a mathematically correct thing to do. We don't use E in our answers. Some teachers may be okay with E. They've just kind of said, fine, I'll take calculator syntax, but not math teachers. We don't do that kind. It's not a real kind. So my choice for writing something like this, I could either write it as a decimal or I could write it in scientific notation. Those would be my two choices. If I want to write it in scientific notation, it would be 4.95 times 10 to the, what, 1, 2, 3, 4, negative fourth. Okay, so those are my options. E is not an option. So if your answer on your calculator has an E on it, do not copy that down on your paper. Okay, I'm just giving you the heads up because it's not an option. You either need to do scientific notation or decimals. Those are the proper ways to write the number. So okay, I'll calm down about that for just a moment. So, are we all good with the concept so far? Okay, so let's go ahead and go to the second page. And we're going to practice this technique. We're going to do probability with combinations. All right, so let's look at our first example. All right, we have 5 cards are drawn at random from a standard deck. Find the probability that exactly 2 are hearts. So we want the probability that we have 2 hearts, and so I need 5 cards, right? So I need 2 hearts and I need 3 non-hearts. I mean, that's what I need to calculate. What's the probability of having 2 hearts and 3 non-hearts? So we're going to use combinations. The total cards I have to choose from are 52. And I want 5 of them. 52, and I want 5. Okay, so let's work on hearts. We know there are 13 hearts. So I have 13 hearts to choose from, and I just want 2 of them. I'm going to multiply that by, because I want hearts and other cards, right? And is multiplying. Hearts and other cards. So I want 3 other cards, and I don't want them to be hearts. So we need to think, well, how many cards are not hearts? We have to come up with that total. It would be whatever 52 minus 13 is, right? Those would be all the cards that aren't hearts, which there are 39 of those cards that are not hearts. and I want 3 of those because my total was 5 cards. Okay, and so that's what I should put in my calculator. So let's just kind of go through entering it into our calculator. I know you probably already know how to do this, but just in case, I need to erase this. Does everybody have what they need right up here? Okay, so I'm going to pull up, hopefully you have your calculator with you. I'm going to pull up my calculator and we're going to enter this. Okay. Alright, so we're going to start from the beginning. I really encourage you to use the second equal, or the alpha equal key to make it a fraction. I really encourage you to use that. It will help you not have to nest everything perfectly in parentheses. So we would do alpha y equals enter, and it gives us a fraction bar. Now on my calculator does have the new system, the new operating system, but it doesn't look like this. So for this operating system, I can just do math probability and pull down that probability, but and it gives me boxes to put numbers in. On my calculator, I don't have boxes to put numbers in. I actually have to put, and this would be 13, I actually have to put 13 in my calculator and then pull down the C and then put in the 2. So depending on which version of the new operating system you have will depend on whether you can just, you know, do this, just type into the little boxes, or whether you have to put the total number in first before you pull down the combinations button. So I'm going to multiply that by, I'm going to go ahead and go to pull, so it's math, probability, and it's number 3. So our other one was we had 39 cards, and we wanted 3 of those. And then in the denominator, let's go math, probability, 3. And so in the denominator we had 52 cards total to choose from, and we wanted 5 of them. Okay. So sometimes in this kind of situation, the calculator cannot handle simplifying the fraction, so it yields a decimal number. In many cases, it's just going to yield us a fraction, but in this case, the numbers are too intense for it. It can't handle it, so it gives us a decimal. In fact, so, you know, I wanted to know what the numbers were. I really like fractions. This is 78 times. The 39C3 is 9,139. And of course the 52C5 was pretty large. 2,598,960. And the calculator could not, and we can see that this fraction could be reduced, right? Because I know at least I could take a 2 out of those, but the calculator could not handle that large of a number because these are being multiplied together. And so it just yielded a decimal. Okay, just so that you know. Sometimes it just can't handle it. It can't handle those numbers that big. So our probability would be 0.274. Okay, for that first event. Is it possible to put probabilities in percent? Yes. Sometimes the question asks you for percent. If it doesn't ask you for percent, I would encourage you not to do that. But sometimes it does, and if I wanted to put it as a percent, I would just turn the decimal to percent, right? 27.4%. That's all I would do. But this really isn't asking for percent. Okay? Are we okay with the calculator input? Right. All right. What's that? Alpha F2. Yeah, perfect. Alpha F2. There's a new, I have never used Alpha F2. I like that. Alpha F2 and then 8. Maybe a little faster than math probability 3. So there we go. That's good. That's a good one. All right. Let me see if I can. My calculator is having such fun. It doesn't want to go away. Okay, there we go. Sorry, little calculator. All right. Okay, so let's look at number 2. So on number 2, we have a scenario of we basically have 3 marbles are picked at random from a bag containing 4 red and 5 white. And they're asking us to match each event with its probability. Okay, so this is how many I'm choosing. I'm choosing 3 marbles. And I have 4 red and 5 white. Okay, so I have a total of 9 marbles. See how all the denominators are 9, choose 3? Right, because that's the total. Right, they all have 9 marbles and I'm choosing 3 of them. So where we're going to have a difference is in the numerator. So let's kind of check out what's going on. The first A says all 3 marbles are red. Well, there are 4 red marbles, so I'm looking, so here's the 4. This represents the red marbles and this represents the white marbles. Okay, because there are 5 white marbles. Do we see that? The totals here, 4 and 5. So I need 3 marbles that are red, so I'm going to look and see. So this would be it, right? I have 4 red marbles and I want 3 of them. I have 5 white marbles and I don't want any of them. So this is a place marker. Some of you intuitively know that that's just going to give us a 1. And that's okay, but it's a place marker. It tells us that I didn't want any of the white ones. So this would be A. Okay, this would be A because that's all 3 marbles are red. Then we want exactly 2 marbles. We want 2 marbles to be red. So again, 4 is the red. So I'm going to go over here. Here's 2 marbles are red and 1 is white. So this one would be B. Okay, we okay with that? All right, the third one, exactly 1 marble is red. So again, we're going to go to the 4 because we have 4 red marbles. Here's 4 red marbles. I want 1 of them. And 5 white ones. I want 2 of them. So this is C. The last case is no marbles are red. So that would be this scenario where I have red marbles and I don't want any of them. And I have 5 white ones and I want 3 of them. So this one would be D. Okay, we okay with that? I'm hoping that helps you kind of get more comfortable with the way that these are organized. All right, our last one, we have 13 cards are dealt from a well-shuffled standard deck. What is the probability that the 13 cards contain exactly 4 aces and exactly 3 kings? So what we want is the probability of 13 cards with exactly 4 aces and exactly 3 kings. That's a 3. Okay, so 3 kings. All right, so that's what we're looking for. So let's start our fraction. So we know the denominator, we want 13 cards, and we know how many we have to choose from. It's 52. All right, that's what we want, 52 cards, and we want 13 of them. All right, so let's start with the aces. We want 4 aces. Well, how many aces are in a deck of cards? There's 4. So there are 4 aces, and I want all 4 of them. And, multiplying is and I want 3 kings. So how many kings are there? There are 4. So I have 4 kings, and I want 3 of them. Now this last part caused some confusion earlier today, so I want to make sure you're listening. So 8 cards, 4 aces, and 4 kings are not eligible to be chosen. Did I use all of the kings? No, but I'm not eligible to choose a king. Right? These 8 cards need to be taken out of the cards that I can choose from for the rest of my 13 cards. I'm not allowed to put these in there even though I have an extra king. Right? Not allowed. Are we clear? So I've got to take 52 cards and I have to take out these 8 that are accounted for in these 2. So I have to take that out. 52 minus 8. And that leaves me 44 cards to pick from. Okay? So I have 44 cards, and how many more cards do I need to have? I mean, I was supposed to have a total of 13, and now I've only accounted for 7 of them. Right? So I would need 6. Right? I would need 6 cards. I have 6 left to go. And we'd put this in our calculator, and that would give us our answer. This is actually too much for your calculator to handle in fraction form as to give you a fraction. So just for fun, of course, you had to see what the numbers were. So we know 4C4 is 1. 4C3 is 4. 44C6 is 7,059,052. All over, and you can imagine 52 cards, choose 13, is massive. It's 635, 013, 559, 600. Okay. Yeah, your calculator cannot simplify. I'm sure that fraction can be simplified. I'm sure it can. It has to be, I mean, unless those are both prime numbers, which seems highly unlikely. I'm sure it can be simplified, but your calculator cannot handle it. So it generates actually one of the E numbers, which we know we don't write down as an answer, right? We don't write E down. So our choices are to write it in decimal form, so that's okay. This is a possible choice. Maybe you like scientific notation better. That's okay too. So 4.45 times 10 to the, 1, 2, 3, 4, 5, 10 to the negative fifth. That's okay too. Either of those answers are acceptable. The E answer is not. Okay? How are we doing? Everybody okay? All right.